All right, well, welcome back, and now let's talk about graphing the cotangent function. So the cotangent function is graphed similarly to the way the tangent function is graphed. So the period is also pi, so the period is still pi. Now the identity, remember, of cotangent is the reciprocal of tangent, so it's going to be cosine x over sine x. And so the asymptotes are going to occur whenever sine x is equal to 0. Okay? And of course, that's going to imply the asymptotes are going to be located at what? Just the multiples of pi. Okay, so that's a little different than what we saw with tangent. So it's going to be equal. It's going to equal n times pi for all integers n. What else? And of course, just like before, right? So if we take y equals cotangent of bx minus c, right? If we have anything like this, where we have this argument, bx minus c, again, we'll find the asymptotes by solving that equal to not pi over 2, but in this case, equal to pi. Because we're going to have asymptotes that are going to happen at 0, pi, 2 pi, negative 2 pi, and so on. Okay, and so that means also because it's shifted over half a pi, that means that the intercepts, the x-intercepts, right, are going to be in between the asymptotes, just like tangent. So we're going to have the asymptote is going to be at pi over 2 plus, plus n times pi. The range, of course, is negative infinity to positive infinity. The domain is going to be all x, obviously all x except where x is equal to n times pi. Just like the tangent, the symmetry is about the origin, right? So cotangent and tangent are both odd functions. Okay, so yeah, it behaves very, very similarly. Okay? And that's it. I think that's all I want to do. So let's do an example and we'll go from there.